cool introduction slide, but briefly, my name is Sébastien. I've been working at SkillZ for about 4 months now. I'm working on the infrastructure side, like basically how we run validators for different customers. And I'm going to talk about how we do it at scale. So yeah, just a brief overview of the agenda. So it's going to be a bit more technical than the previous talks. And like if you want to leave, like feel free to do so. I'm going to talk a bit about Pocket and SkillZ, then about topology, which is a problem that emerges when you start having a lot of validators. Then I will talk a bit about automation and finish with instrumentation, like monitoring and this kind of stuff. Okay, so Pocket is a proof-of-stake blockchain where validators get rewards by serving requests from different decentralized applications towards other chains. The mainnet started about 1 year ago, and as of today, there are about 5K validators. So it's a different number than the one from Adam, but I think I checked like 1 week ago when I started making the presentation, it was 5K, but it fluctuates a bit.
I was being conservative.
So this is the basic model of how it works. There is a gateway missing here, but I just simplified it a bit. So you have decentralized applications. They target Pocket validators, which are connected to different blockchains, and the validators are serving requests, and in exchange, the validator gets some portion of Pockets. So that's the basic model. So our job here at SkillZ is to run those green validators and also the backend side, and like be able to basically scale this part here horizontally so that we can have like thousands of validators. Well, this is what I just said. So yeah, as of today, we have about a bit more than 1K, probably 1K and 400 validators running. So let's talk about topology. So Pocket uses peer-to-peer, uses Tendermint, like a fork of Tendermint for the peer-to-peer communication between nodes. And topology is basically how you organize your nodes so that they have good peering together and they can like contribute in a good way to the network, because network stability is something very important. And there are different approaches to do this. And usually when you run 1 or 10 nodes, it's not a problem. But when you start running hundreds of nodes, you start getting big issues in this area. So you need to have like some sort of constructs. And we are going to see different approaches. This is kind of like how we adapted a good talk from Ben Van, who is also like a guy, like a good guy, like the Pocket community, who made a 1-hour talk about topology. So I'm reusing some of these ideas, but like if you want the full story, I think his presentation is very good. Same slide. As I said, Pocket uses Tendermint for peer-to-peer communication. Peer-to-peer was made to run like hundreds of nodes at most globally, and Pocket uses like more than 5K validators, which means that there are a lot of issues that arise because of like the initial implementation of Tendermint was not ready for this kind of usage, and which is why Pocket uses a fork of it. So this is how it works when you basically run 1 validator. So typically what you are going to do when you start the validator, you are going to connect it to a seed node, which is a node that has like a good presence on the network and knows about all of the peers, or not all of them, but a big portion of the network, and it will output a list of nodes to connect to, and then the validator is going to connect to those nodes and get more peers and discovers the network little by little. And this is what is also called PEX reactor for PEX exchange, peer exchange. And this is somewhat automatic, as in you just connect to a seed node and then your node is going to make its life. And once it's connected to peers, it will start getting blocks and distribute them to its peers, and like things are going to go well. So this setup is very easy to put in place because you don't need to have like specific constructs. It's dynamic. You don't need to edit your configuration in weird ways. You just need to like point your node to a seed node, and then things are going to work. It takes some time to have peers, and you have basically no control about the quality of peers. So if you have bad peers, let's say you run 1,000 nodes, maybe 10% of them are going to get good peers, which means they will get good performance and good rewards. Whereas, but it's not going to be like evenly distributed across all of your nodes. So when you run at scale, you have like this sort of issues. You are aiming to have like some sort of stable network, but you can't get it if you go with this approach. So this is what most node runners use, like the sort of approach you use at scale. So the pocket validators are here. They are like directly connected to full nodes, which are then directly connected to a tower node. So the tower node can be seen as a sort of a highway on the network. It's like a node, or a set of nodes that are like highly connected to other big node runners. And by connecting to them, you will get a lot of good peers and this sort of things. There are two levels here because the links here have to be statically defined in configurations, which means that if you run like hundreds of nodes, each time you add a node to your network, you will have to edit the configuration to add a new link here. And you basically don't want this part of the network to be unstable because like if you have to restart it 5 times a day to add nodes, like your setup is not going to work well. So this is why people use a sentry approach where to add a new node, like you basically batch creation of nodes and create a new sentry node, connect it once to the tower, and behind you have flexibility to restart it way more easily. I don't know if that makes sense so far. I'm going a bit fast. Okay, thanks for the support. Okay, so the pros of this, well, the advantages of this approach is that it's scalable and stable, but as I said, it requires quite a lot of manual work. And when you do it like with 1,000 nodes, it's not something you want to do. Like you don't want to manually add new sentries or have to touch configurations every time. I'm going to talk a bit more just about this part, like this full node, which is something that has to be very reliable. As I said, it's kind of like a highway on the network. And if this thing goes down for a big node runner, then connectivity of the entire network may be impacted. So it has to be very robust. And usually what we do, so this is what we do at SkillZ. Our tower is actually 5 nodes, which are interconnected together. So each node is connected to all of the nodes of the tower with like static configuration. And each node is watching its neighbor to be able to detect if there is an issue with the current node. So basically, by looking at the block height of each node, you kind of know your current state. Like you know if you are ahead or if you are behind. And if you are behind, then there is an issue, and you probably want to automatically restart your node. And this is what we do, basically. And so this kind of structure is quite cool to work with because, like, if you want to make an upgrade, you can shut down 2 nodes. Like, things are still going to be fine because there are still 5 nodes. We pick 5 because we want a lot of flexibility on this side, but like some people use 3. It depends. Yeah, so this is actually the topology we use at SkillZ. So as I said before, one of the biggest problems of the sentry approach is that you have to manually create sentries and connect them to nodes, and this is not something we want to do because we want to be able to start new nodes within like 5 minutes or so we need something automatic. So what we do, we create 2 towers, like a public one, which is like the highway to other nodes on the network, and a private one, which is interconnected with the public one. And this one does not have access to internet. It's only like an internal tower to which only our validators can connect to. So basically, this one is set in open bar mode, where it accepts any connection, but we trust all of those connections because it's a private network. And that way, we are able to start hundreds of validators without having to change the configuration of any of the static parts of our topology. And yeah, we basically connect validators to 2 nodes of the mesh so that if one of them goes down, connectivity is still okay. Okay. So I think, yeah, the next steps, as I said, Tendermint is not made to run like hundreds of nodes like this. And I think like there are some features that could help a lot, like new configurations or this kind of stuff. So I think it would be cool if we could like maybe add a way to feature peers by subnets in the Tendermint configuration of this kind of stuff. So I have a lot of ideas. If you want to scale up topology-wise, I can. So yeah, that's for the first part of the presentation. Do you have like any questions on topology? I know I was a bit fast, maybe, or.
That's very good. Do you have questions?
I have a question. From where did you get the ideas to think of this topology?
So it's mostly an extension of what Ben Van is doing, basically. Like his talk from the topology was like what I described a bit before, but not dynamic. And at SkillZ, we really needed to have like something dynamic because we want to be able to spin up nodes within minutes without having to set up a configuration in place. So that's a kind of adaptation of his early work. And you also can find quite some documentation about these approaches in Tendermint's configuration, Tendermint's documentation, but it's not made for like 5,000 validators. So a mixture of Tendermint and Ben Van.
and do you take inspiration from, I don't know, models from the nature or that kind of thing, natural models?
Underlying question, yeah. I read some papers about how trees, mushrooms can these huge mushrooms that spawns like kilometers and like, I forgot the English name for it. Is it slimes? Anyway.
It's like mushrooms.
Yeah, mushrooms. Like if you read about mushrooms, they also have like topology construct and all because they need to be resilient and like if you cut them in two, they are going to make their own lives, kind of spread in different directions, and it's quite interesting. I think there are some parallels.
What kind of mushrooms are these?
I forgot.
And you have these kind of mushrooms after the talk. Actually.
Yeah, it's under the swag. Okay. Now let's talk a bit about automation. So I'm just going to describe one automation mechanism we have in place, but we have many different ones. It's one way of doing things. So as I said, we want to have nodes that start within a few minutes or so, and synchronizing. Like when you start a new validator, it has to synchronize from the chain, and like the chain is like 30K blocks or something. And if you start from block 0, it's going to take days for the node to synchronize, to download basically all the data from the blockchain. And like the blockchain actually is currently 60 gigs, I think. 56 or so it will take time. If you go by using peer-to-peer communication, like because it depends on your peers. If you get bad peers, it's going to take 10 times longer, and so on and so forth. And we want to be able to start nodes within 30 minutes. So what we do is we have nodes that are already synchronized. We call them sync nodes. Every 2 hours, we stop them and we push their data state, which is like the blockchain, to a S3 bucket, from which our validators can then start immediately after. And so when the validator is going to start, it will already have a dump of the blockchain at a quite recent state, and it will only have to synchronize at most 10 blocks or something like this. So it's quite a fast way of doing things. So we started doing this that way, and we had issues at SkillZ where sometimes nodes can crash, and if they crash in the middle of, let's say, I don't know, they can, for instance, use too much memory at one moment and be killed by Unix or whatever. And if it happens at the moment they are writing to the disk, the database is going to be corrupt. So what we are going to push on S3 is going to be corrupt. And so we had some outages like this. So to increase reliability, what we are doing is we start we have multiple sync nodes running in parallel, and we push their data states to different buckets. And whenever a validator is going to start, it's going to pick a random bucket from the list of buckets we have. And so if one of the buckets is corrupt, the likelihood that it will fail is going to be divided by 3, basically. And we have in place some automation to detect that the node cannot start, and it will restart in loop like this. So as the probability, I think it disconnected. Is it working? Next slide. Okay, so yeah, the probability to have basically as the node restarts on a random bucket, the probability to hit a crashed bucket is going to decrease with time. And so yeah, that's one way to approach automation. Anyways, let's continue. So this is a graph of our sync nodes. This is the current height of the node compared to the network. So you can see it makes little steps. It's whenever a new block arrives. And the vertical stripes are just whenever we stop the nodes, push the state to S3, and then, we have automation for different things. So we have automation for late nodes. Whenever a node is late, we are going to automatically restart it. Staking, to stake, like whenever a node is not staked, and at head, we're also going to stake it automatically. So yeah, all of these things are things like because we manipulate like thousands of nodes, there is no way we can say change the machine type of one node like 1,000 times. So we need to have like some sort of scalable automation for this. And yeah, this is a small list of what we have behind. Any question on automation or? Yeah.
Yeah, I guess it's kind of a more of a general point, but I guess it'd be interesting to know how different it is to support Pocket to maybe any other networks that Skill supports in terms of like all of the automation and the things you're doing. Is it extremely unique and kind of proprietary just focused on Pocket, or?
Yeah, so we use Kubernetes, and there are some parallels. Like basically everything that is Cosmos-based is going to use Tendermint. So the topological constructs here that we have for Pocket, we can reuse them for other networks. And then like the concept of a jail node and staking and all, this is also something that can be approached from higher level where you have like some abstraction in place and so we use Kubernetes and Helm, and we have like the scripts are sometimes common, and maybe the tools are going to be different behind, but you definitely can scale horizontally with more protocols, and adding a new protocol is not going to be maybe like 10, like I don't know. If you spend 1 year like supporting Pocket that way, maybe like supporting another protocol in the same way is going to take, let's say, 2 or 3 months instead of a year, and so on. Yeah. Other questions for automation? Okay. And finally, I'm going to talk a bit about instrumentation. So it's instrumentation is what you need to get metrics to know what to do with those metrics. For instance, I mentioned before that we had automation to stake or unstake or like unjail a node, and to be able to automatically unjail a node, you need to know that the node is jailed in the first place. So you need to have like some sort of metrics that are somehow fetched from production. We use for this Prometheus. Prometheus is some sort of internal thing that was used at Google, which was made open source a few years ago, and there is like an open effort to distribute this everywhere. And Tendermint has a support for Prometheus as well as some parts of Pockets, but not everything we need. So we also have our own instrumentation on top of it. So to get this instrumentation, what we do is we have a sidecar process. So it's like a process, like a Go process, which runs at the same time of a validator. And every 5 minutes or so, it's going like to poke the validator, get its state, and like try to get more information from it, and then publish it to Prometheus. And with this, we get like new sets of metrics we can play with, like even business metrics, which are like not very technical. So for those who are familiar with like Ethereum and Prism, it's a bit like client stat, I think, or there is something like this which uses the same approach on Prism.
Yes, yeah, it's like Prometheus Graph now, Prism open source way of monitoring it.
Yeah. So this is some like example of metrics we fetch that way. And like because it's a Go process that does this, it can do whatever we want. So what we do is, like one of the problems you have when you run like validators like this is that you don't know if your validator is wrong or if the network is wrong, if there is some issue with the network. So you need to compare your current state with the state of the network. So you need to have like your monitoring be aware of both sides and take decisions based on those. Like for instance, if you have one node that is like at block 20 and you see that the network is at block 30, you know that your node is late and there is a problem with your node. But maybe, basically you need like to have 2 sets of data to compare them and then take decisions. And for this, like having custom instrumentation is very helpful. And so for those who are familiar with Kubernetes, I don't know if there are many people familiar with it here, but the Sentinel, so the sidecar process that was mentioning is exporting an HTTP endpoint to tell whether or not a node, validator node is healthy or not. And you can configure Kubernetes to poke this endpoint every now and then. And depending on the return value, it's going to take an action. And the action can be restart the node. And this is how we basically detect late nodes. We have like the sentinel that exports the healthy, compares the current state of the node with the one of the network. And if it's like stale for more than 30 minutes and late for more than 30 minutes, we decide to restart the node. And to do this, we define a probe that is like, this is how we define a probe on Kubernetes. And so here it's actually different numbers. It's like every 10 seconds, we are going to poke the sentinel. And if it fails 15 times in a row, we are going to automatically restart the node. So next steps for instrumentation, maybe, we are thinking about maybe open sourcing the Sentinel if some people are interested in this approach. And we're also working on having some sort of real-time visualization of our topology, where the Sentinel basically can scan all the peers of a node and push them to like a graph database, and then we can like have some sort of real-time representation in 3D or whatever. There are like cool frameworks for this. I think that's all I have to say. Sorry, that was a bit technical and fast, but if you have any questions, now you can.
Hi.
Hi.
Nice presentation. So Sentinel will get metrics from the node, and then Prometheus will scrape Sentinel, right? So like it's a middleware sort of. Why not create a Prometheus endpoint for the node itself? Because you want to choose to.
Because like we are not like we don't touch Pocket code directly. We prefer to have our own instrumentation. Like we don't want to fork Pocket and like have a terrible bug because we had some instrumentation inside it. So we don't have control on the. We are just running Pocket nodes. So we prefer to just use the official version of Pocket. So that's why we don't instrument ourselves Pocket.
And how does Sentinel takes the data from Pocket?
So we usually use, so there is a Pocket CLI, which like you can have commands like Pocket query node or whatever. And it's going to give you some status about the node. And and also another reason is that if the validator is running and suddenly like totally irresponsive or exporting stale metrics, you're not going to detect it if you have another process that is like totally safe, not safe, but like, I don't know, if there is a bug where the validator is completely stuck, Prometheus is not going to detect that something is wrong, right? Because the process cannot export the metric, so there is a sort of chicken and egg problem. So that's why like having two processes is better.
If the node is stuck for some reason, then the metrics will get stuck. So Prometheus
can be a bug, like
you will see. I mean, if you have the Grafana dashboard, you will see the metrics start not making sense, right? You will see like why this chain head is stuck at.
You will see something, but like if you build automation on top of it, like you have to take decisions on like data you
on the alert manager level, like what's the threshold?
So for alerting and monitoring, it's perfectly fine. But when you start taking decisions, like if the node is not responsive, like you don't know what state it's in, so you don't want to like. Whereas if it's a separate process, you can know kind of like the state machine in which it went, like maybe it was jailed and it was unjailed and it started like.
And add more business, like more custom logic inside Sentinel, so you can have more advanced and easy alerting on top of that.
Yes.
Yeah, okay, that makes sense. Thanks.
Any question? No? Well.
Thank you very much.
Oh, there's one question.
Sorry about that. I have a more general question about Pocket. You said you have 4,000 nodes in the network, right? Do they come with packaged Ethereum full nodes, or how do they do queries to blockchains?
Yeah, so the ratio, I don't know what the ratio. Thank you. So that question was like full nodes versus validators on the network?
Well, I mean, like the value proposition of Pocket is decentralization from Ethereum, right? So there should be many Ethereum full nodes that you query in the end, right? Because if you just have a lot of nodes that all send requests to Infura in the end, then like what's the value, right?
Yeah.
So I was trying to understand the kind of the numbers here. What amount of full nodes being run by Pocket Network, Ethereum full nodes, or how does it achieve decentralization in a different way?
Yeah, I mean, maybe Seb, how do you guys Pocket validators versus full nodes that you guys run?
How do we, sorry.
Like so the ratio of validators versus like Ethereum full nodes.
Oh, so I think it depends on the performances you want, but of full nodes, sorry, you mean ratio of like Pocket validator versus Ethereum full nodes, right?
The question is, Infura is a company, right? Like the value proposition of the Pocket is we decentralize Infura. Infura is a company. Infura in AWS runs a lot of Ethereum full nodes, and they have Kubernetes. They all have all this stuff, right? It ends up with a single endpoint that we all query, and we all happy, but we are not happy because it's not decentralized. So I was trying to understand is Pocket Network gives me ability to query one of these thousands of nodes in the network randomly. But these nodes these Pocket Network nodes should in the end query some Ethereum full nodes, right, to get the data from the state. So, and I was trying to understand like how many of these nodes in the end?
I think there's probably somewhere between 500 to 1,000 Ethereum full nodes to our 5,000 Pocket nodes.
So basically it's a 10% of Ethereum network.
Yeah, it could be. Yeah, I mean.
On our side, I think it depends on different node runners or different setups. On our side, like just for SkillZ, we have a cluster. Like we probably have 5 full nodes of Ethereum, like with very big configurations, and we can scale them up if it's not enough. But yeah, for us it's like smaller number, but we use like big machines. But maybe different setups have different needs. So.
Yeah, but I guess as well the like proposal to be decentralized, the number of full nodes spin up by Pocket is like Ethereum full nodes is interesting, but at the end of the day, Infura might, I don't know, run 200, 300 full nodes for what, several billion requests a day. The thing is, it's so centralized, right? It's AWS, maybe 1-2 region, that it happened before, or even using the same Ethereum clients get. If there is a problem with a client, if there is a problem with AWS, if there is a problem with a region, they might run 1,000 nodes, the whole service will go down, right? The thing with Pockets is that even if you have, I don't know, 5, 10 nodes through the force big provider that actually support Pockets, because you have obviously smaller node provider or even single node runner on Pockets. But at the end of the day, what makes the topology stable and the whole system performance is 4 to 5 very good node runner. If one of these node runner goes down, obviously the network will still remain. And if 2 of these big node runners goes down, same thing. So I think, this is really a kind of advantage, or even like this is really a kind of progress that you see on Pocket and that you don't see on Alchemy or Infra or any centralized way of accessing blockchains.
So, like, if in the end there is fewer Ethereum full nodes than Pocket nodes, then what's the reason to have the Pocket nodes besides just load balancing between those full nodes?
Yeah, so every Pocket node has the same chance of doing work as every other node. So the minimum is 15,000 Pocket, so you're incentivized to continue replicating your own Pocket nodes as you continue earning Pocket. So you might have 5, 10, 20 Pocket nodes, or in their case, hundreds to one single Ethereum node, right? But you are incentivized to actually split up your validators due to the way the economics work. But it's going to look very different at scale, right? So right now, Pocket's not actually processing a huge amount. Yeah, it's like 1%. Like we're not even probably using 1% of the compute of the network right now. Yeah. We don't know what that ratio might be, but yeah, we'll see as we grow for sure. Hopefully did that answer your question?
Yeah, maybe. Yeah, I maybe ask more questions after. Okay.
Cool.
Thank you.
Yeah. Someone's.
What is like the latency of Pocket compared to other like providers like Infura?
Yeah, good question.
It seems like this seems like pretty complicated.
Yeah, so in Pocket, you're querying just a raw full node. So right now we're between 300 and 400 milliseconds for most requests. And Infura, Alchemy, they'll probably serve you some data depending on the type of request between 150 and 250 milliseconds. That's usually because they have cached data or indexed data. And right now, at least with our node runners, it's just a raw Ethereum node. Eventually, we'll release some packages that allow the node runners to have some local caches, indexes, and so on and so forth, where we'll kind of get to parity on that front. But that's kind of the kind of difference right now. Just for context, when a page loads, you usually, the human site doesn't perceive it between, until after 250, 300 milliseconds, as an example. So it's pretty, it's pretty fast. It could be faster, and we'll get there over these next kind of 6 to 12 months.
Okay.
Yeah, good question.
Any other questions?
There's been a lot of talk about MEV lately, flashpots and all sorts of stuff. So, a lot of towns they say, don't use Infura. Because you want to run your own node to be the fastest, or maybe the infrastructure will actually front run you. So I was wondering, have you done any research on that front? How are you thinking about that?
We're still early in thinking about it, but node runners are in an interesting position in Pocket, given that issue. I think there will be some opportunities. I'll be honest, we haven't looked super deeply into it yet, other than I think there will be some interesting opportunities for Pocket with MEV and this kind of thing for sure. So just because it's a network of people running, these nodes, and they're the ones receiving the transactions, right? So whether it's applications, in the future being paid, right, for certain things, right? So
would it be possible for I'm not sure how Pocket exactly works. I'm super new to this. But I was wondering, for example, Flashbots, as a miner, you can sign up so you can receive bundles from Relayer. I imagine that Pocket would be like a single interface to that Relayer. So that would make sense. Have you thought about yeah?
Oh, I'm sorry. What was the question?
So the question is, I'm thinking right now. I'm trying to see if it sticks. How Flashbot works basically is that a miner can receive bundles of transactions through the Relayer, but I imagine from the outside, Pocket is a single miner, like it's a black box, right?
Well, in this case, Pocket would be the relayer, not the miner, right? You're running full nodes, not necessarily validators.
No, I think no. It will be the relayer. It's just a private entity that basically tells you that I will not leak your bundle. Yeah, and now it's trusted by the Flashbot team. Like you can send me the bundle, and I will not front run you. Yeah. But the miner might. I don't control that.
Gotcha.
So maybe it would be interesting, like if the Pocket network could hook into that Flashbot, so random Pocket, they would receive bundles or whatever. I don't know.
I guess we had Flashbots on Tuesday, and as you said, if you want to do MEV through Pocket, Pocket will be the relayer. So in spite of a full node, Ethereum full node, you will need to run like a validator, staking validator. Yeah. And the staking validator will install Flashbots and read the bundles from a transaction that has been relayed by Pocket, right? And in this sense, maybe MEV could work, but again, like the bundles, I think won't be read on the Pocket network. You see my point?
Gotcha. Yeah, I think. Okay, now I see it.
We are a relayer,
Yeah, right. You're a relayer.
We just relay these.
Interesting.
These RPC requests.
Cool.
It's really thin middleware.
Yeah. I gotcha. Yeah, you're right. Sorry.
Yeah.
Cool. Thanks.
Questions?
Thanks, everyone. Well, thanks for coming.